Good morning, class. So today we are going to discuss another substitution method, which is called polyalphabetic cipher. So polyalphabetic cipher is a substitution cipher, just like other Caesar cipher, monoalphabetic cipher, and plain cipher. It is also a substitution cipher. So in this one, we are going to improve the security using multiple cipher alphabets. So instead of having in the monoalphabetic, you observe that only 26 cipher alphabets are there, and in the Caesar cipher, we have only one single alphabetic cipher is there. So here, what we can do is we can use the multiple alphabetics to perform the cipher algorithm, where we are going to take a key to select the alphabet is used for each letter of the message. So one key will be taken which can be used for all the alphabets. Use each alphabet in turns. So we are going to repeat from the start after end of the key. So for example, you can take the key. So simplest polyalphabetic substitution cipher. If you observe, we are going to take the key length as long as k is equals to k1, k2, k3, k4, and the letters I letter will be specified as the ith alphabet. And we are going to use this letter and repeat the letter, and finally we are going to substitute the letter. So based upon the key, we are going to substitute the letter with another. So this is the chart for polyalphabetic cipher. For example, if you are having we are going to have a key and we are going to have a word. If you are having a key, if you observe, this is the key. The upper letters will be considered as key, and downwards we are going to consider as a cipher text. So if you observe, we are having the cipher text. Your plain text M. N is the plain text, and if the key is N, then we are going to consider A as the cipher text. For example, plain text A, and if you consider key as G, then we are going to take your cipher text as G character. If a plain text is C, and your key G is the key, then our cipher character is I. So like that, we are going to use these keys. Particular keys will be there. If key is A, then same whatever the plain text is there, same plain text will be considered as a cipher text. If key is B, then one letter, just like your Caesar cipher, one character will be moved. So like this, we are going to change, and these many keys will be available, and we are going to perform the operation in this fashion. And monoalphabetic cipher is more secure compared to other. Polyalphabetic cipher is more secure compared to your monoalphabetic cipher. And best example for the polyalphabetic cipher is dictionary cipher. In the dictionary cipher, we are going to take a plain text and write the keywords and repeat the above keywords. For example, you can see the keyword is deceptive. Deceptive is the keyword, and my plain text is we are discovered, save yourself. Okay. We are discovered, save yourself is the plain text. Now to convert that plain text into cipher text, what we need to do is we need to repeat the keyword to generate a key which is equal size of our plain text. So whatever the plain text size is there, same size key should be generated. To generate that particular key, we are going to use the keyword. So deceptive is the keyword. We are going to repeat the deceptive multiple times to reach the length of that particular plain text. Suppose we are required here, we have repeated the keyword deceptive, deceptive, and deceptive 3 times. So this is the key. Now what we are going to do is, we are going to see the what is the keyword key D and what is the plain text W. D and W. So we are going to move back to the text. So your keyword is D and W is the plain text. So your plain text W will be converted into Z. Like this, you can observe here, it is converted as Z. Same way E is there. And our plain text is what? Plain text is key. So, and key is also key. Key is E, plain text is key. So go to the matrix, key is E and plain text. Your plain text also key. So what is the letter we are having here? I. So this I will be substituted. So E will become I, A becomes C, R becomes V and D, like that we are going to generate the cipher text. So because of this visionary cipher, it is unpredictable which characters will be substituted by which one. Okay? Hence it is not possible to see the letter frequencies, and it is the letter frequencies will be very difficult in the polyalphabetic cipher. So that is the advantage of your polyalphabetic cipher. The next concept we are having one-time padding. So one-time padding is a truly random number key generator. So in the one-time padding, we are going to substitute based upon the random numbers. Okay. So we are going to generate a key as long as message is used, and the cipher will be secure, okay, called as one-time pad. So it is unbreakable since ciphertext bears a non-statistical relationship with the plain text. So unpredictable ciphertext will be generated here, and here what we are going to do is random number. Randomly we are going to generate the keys. Random number generator will be there, which is going to generate randomly keys, and we are going to substitute based upon those keys. So this is called your one-time padding substitution. So these are our substitution methods which we have discussed in our class. We have seen the Caesar cipher, where we are going to use single key as a input, and only 26 keys will be there. Then we have seen the monoalphabetic cipher. In the monoalphabetic cipher, we are going to have the key string, which will be 26 factorial. After that, we have seen the playfile cipher. So in the playfile cipher, we have converted our key into matrix format, and we are going to pairs will be converted into your ciphertext. And we have seen the polyalphabetic cipher. So polyalphabetic cipher will converts the complete message into random string, and one-time padding cipher which will generate the random key. Truly random key will be there. So each time we are going to add this random key to substitute the plain text into ciphertext. So this is the class for your substitution method. So in the next class we will see the transposition method.